Hello everyone, welcome to my channel Cryptoware. Welcome to day 3 of alternate day RE challenge. And today we are going to solve yet another challenge from crackmes.one. I'll share the link of this challenge in the description below. And meanwhile, let's get started with this. We'll check whether it is 64-bit or 32-bit using PE Studio. While downloading the sample, you can get all the details related to this in the challenge description only. However, I had downloaded it a bit while, so I don't remember. So it is 32-bit. So we'll use X32 debugger. So for every challenge, we are focusing on learning something very different. It could be a easy thing, it could be a trickier thing, but whatever they are all meant for the beginners at the beginners level, and you can solve these challenges with me. So before that, we have already opened it in X32. We will see how does it look like. So it asks for password. It is given by Dejo. I hope I am naming the name. I'm pronouncing it correctly. I'm sorry for the mistakes. So we'll write anything. This time, let's enter the password as hello. And you have entered the wrong password. So this is the string that we should be looking for. Enter password is another string that we should be looking for. We have always been following the same steps. So here also, after opening this, we move to the entry point and we'll be looking for the same thing. So right click, search for all user modules and string references. And yes, we have this. We have something. Is this a password? We do not know. But what we will do is we will set a breakpoint to all of this. And meanwhile, I will just check. So there's some comparison. So mostly this could be a password. Let's see. We will check. We have done this before. We should understand whether this is a password or not. And then the challenge will be solved right directly. So we'll just copy this. Let's open this. Run this, save the paste the password. And no, this is the wrong password. But what is this? Okay, never mind. Let's start with our analysis. So we'll click on continue, enter password. Have we gotten the not yet? We'll click on it again. Let's see, yes, enter password. So let's put password as admin over here and let's see. So here is the EIP instruction pointer. So this is used somewhere and ESP, this is ZWNRM. Okay, so our password that we had put is of 5 letters and this is also of 5 letters. So most probably something is happening, some sort of calculation or some operations are happening mostly. Let's try this again. Let's change the length of the password and let's enter the password as password, which is of 8 letters. Let's see if we can see this is 1, 2, 3, 4, 5, 6, 7, 8, which is interesting. So something is happening, few things are getting changed, the characters are getting changed. This is not a hash or something. Some kind of cipher we can call because it's not readable. And if this is the actual password, then the actual if this is the transformation that is happening, that is this is the cipher of the input text that we have given, then this should be the cipher text of the actual password. So sorry. So here we have to identify what is happening. We have notepad. Let's put it here. We need to figure out what this could be. But meanwhile, we can check. Like for password, it got changed to, sorry, it got uh, changed to KZHHDLIW. Let's try this again because we had put admin. So maybe we can identify something. We need to find a link between admin and password. I mean, these two inputs that we are giving. Okay, let's go. This time we'll put admin and let's see. It is ZWNRM. Z, sorry, it should be here. ZWNRM. At this point, we can follow some other approach also. Like in the first session, we did use Ghidra to check how is the conditions happening, how is the check happening. We can do the same over here also. But right now, we will try some other trick. We'll try to understand what is happening. Okay. So here A is getting changed to Z, D is getting changed to W, M is getting changed to M. Let's see if this is the same. P is not there. A is getting changed to Z. Do I have any other thing? Let's put some other password. Uh, let's put what all characters do we have? Password. So let us put A D WARE, adware, so that I can check. E is not here, so let us keep it till here that whether the change is the same. So the substitution, if the substitution is happening the same, like for every whatever password we provide over here, the letters are getting changed to something static. For example, is A is always getting changed to Z, that is something that we are going to check over here. Okay, sorry, I just ZWDZI. Uh, let's see. ZWDZI. So A is getting changed to Z everywhere. D is getting changed to W. W is getting changed to D. That is also interesting. A is getting changed to Z again. R is getting changed to I. So this most probably looks like a substitution cipher. So there are different ways that you can actually follow. You can write a script for substitute cipher. You can also follow another way, like I'll show you another trick that you can do is you can characters count the number of characters over here. Here numbers are also there, so we need to see how the numbers are also getting changed. So if I copy them all, so the password excuse me, password is of length 18. So we can enter a password of length 18 over here, and we can see how is it getting substituted to. For example, I'll put A B C D E F G H I J K L, and if it is not even 18, let it be, let us keep it till MN. Excuse me, and let's enter. And here is the change that is happening. So let's see the comparison properly. D E F G H I J K L M N. So this was the password that we had entered and it got transferred to ZYXWV. If you can guess this correctly, yes. So the transformation, I mean the substitution is happening with the letters in the reverse order. So you can actually write a script to find out. I might have missed something over here, but don't worry. I have a proper uh, file where I had actually mentioned it. Sorry. We'll open this substitutions.txt. And here you can see that A is getting A, B, C, D till Z is getting substituted to respective letters starting in the reverse order. So you can actually change it. You can write a script to find the actual password, and the same thing is happening for the numbers also. So I can show you if I put numbers. If I put 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, we can see that it starts from 876. So 0 gets changed to 9, and vice versa, and so it starts from 0 basically. So you can see that you can, this is a substitution cipher that is happening. And here you can actually write a script to find the password. But even since the password is, this can be done manually also, and you can write a password for this. You can use a script also. You can check from here. So what we will do is, where is the actual password? Yes, we can take help from here. So H is getting transferred, getting changed to okay. So we'll see where is H is getting changed to S. F is getting changed to U. Y is getting changed to B. And if you keep following this, we'll get the password. So I have not written any script for this. This will not take much time. You can write a script. I did not write though. So you can calculate it by yourself, or also we'll see, we will check over here whether whether our calculation is correct or not. So after solving the password, following the same from here, we see that the password is substitution box 420. Also, the thing that we have to see is the caps lock. So in between there are two letters which are capital. And after making all the changes, again I'm saying that you can actually write a Python script or script of your choice. There are there are scripts present, there are online tools present, so you can take help of that. If you want to do manually, you can do. Since this was very small, it did not take much time for me to do. And after a while, like after put uh, adding till substitute or substi, I could understand it is talking about substitution or substitute. So it did not take much time. You can follow, you can identify what is happening from there. Also, sometimes we do the calculations that way. Let's check if we have identified the password correctly. So let's run this, enter the password. Yes, it's correct. So we'll put the correct password over here also. We did not even have to do complete, reverse engineering also. Sometimes seeing the code also helps a lot. Now here you can see this is where the changes has happened. Before coming to ESP, the change is already happening. So what we can do is we can put some breakpoints here as well in these functions, and we can actually look if there is any calculations that are happening. So for example, I'll again run this, and we'll enter the password. Where are we right now? In move. So you can see that some movement is happening over here. This is where our password is present. So from here the calculation is actually happening. So we'll do step into and ESP10. This is happening. Here you can, in the registers, you can keep an eye what is happening. Jump backward. And here you can see some changes are happening. So one by one, it will keep on happening. We'll see how this is getting changed. It will again move. So this is the loop that it is following. If you keep following the loop, you will see how the transformation is happening. So right now we understood while analyzing the passwords continuously, right? We entered two, three passwords, we identified there is some link in the password in the substitution that is happening. But here you can see that this is the loop which is actually following this substitution, right? This is the loop. So this loop would have also helped us even if we were not able to identify it from there. After changing it, it is checking it over here. You can see again the same jump not equal to. If there are conditional jumps just above that, you will see there is comparison or test, some sort of function is being used. So here you can see the complete transformation is happening over here. And here you can see the complete transformation is present in the ESP, and then the comparison is happening, and based on that, here you will see again the comparison jump not equal to. If you go to jump not equal to, it's here, and you reach fail. But if the jump is equal to, like in our case, like its comparison is happening here, jump not equal to is not happening. So it is again checking. Again, it moved here. It's doing again some comparison. So it's continuously, there are different loops that it is following to perform. It is checking. So you can put breakpoints over there also. But we have figured out that how we can solve the challenges. Sometimes, sometimes we're not able to identify the logic, and sometimes it's possible to identify the logic. Okay. So if you can perform some basic reverse engineering challenge, sometimes it gets easier for you to understand how the challenges are being solved. And here you will see that this is where the final test is happening before getting to congratulations. So that's it for today. Let's run it so that we can see the final output. Yes. That's it for today. So we in this challenge we identified how substitution cipher is being used. Substitution is used for making some changes in the password, and when we observed that and we actually identified the logic, we could deduce the password by ourselves. However, we could also see that how loop operations was being used to perform the substitution over here, although we did not take help of that. So we will be solving such kind of challenges which are kind of similar to each other, yet there are certain things which are slightly different, and we are going to learn something out of that challenge. You can follow the entire step, you can solve it on your own. Again, it is not important that for solving an RE challenge you have to go through the code entirely. You can always use your brain, you can use your logic to see what is happening and how easily you can actually understand or guess the password or see what is happening. Sometimes we do not need to solve it completely, we do not need to do each and everything till the end to get the password. So that is how we solve challenges in the CTFs also. It is not at all required always to get to the end of it. Sometimes before that we get the idea, we get the answer, and we should be having and following that approach too. So we'll see in the next video in the day 4 challenge, and meanwhile keep practicing and let me know if you have any suggestion. And see you. Please like, share and subscribe to my channel.